This is the video to go over your study guide for the Chapter 2 test. This study guide is going to be a lot like the tests, probably the exact same questions with just different numbers. Problem number 1 says, does the NBA player Carmelo Anthony of the Denver Nuggets have a greater ability to shoot at home than on the road? He made 349 of his 728 shot attempts at home and 339 of his 774 shots attempts on the road during the 2008-2009 regular season. Problem A says to display the data in a two-way table. So the first thing I'm going to have to do is create my table. I'm going to need 4 sections going both ways. Total. Then I got to look at, okay, what am I looking at? We're looking at shots made at home and on the road. So I'm going to put made shot, missed shot, home, road. It does not matter if you put these here or here. We're still going to calculate it the same way. So according to my information, he made 349 at home. So 349 out of a total 728. So if he made 349 out of 728, that means I'm going to use a calculator and I'm going to do 728 and subtract 349. So 728 minus 349 gives me 379 missed shots at home. Then I'm going to look at, okay, his road games, he made, I don't like that color. Choose a different one. Let's do pink. I hate pink, but we'll choose pink. He made 339 of 774. So he shot a total of 774. He made 339. So 774 minus 339 means he missed 435. Now, to calculate these boxes, you're just going to add the columns down. So 349 plus 339 gives me 688. 379 plus 435 gives me 814. 729 plus 774 gives me 1502. To check to see if your math was right, you can always add these two and see if you get the same thing. So I'm going to check it real quick. 688 plus 814 gives me 1502. So therefore, this is my two-way table. This question is asking for problem number 2, or part B, is to state the null hypothesis. Remember, the null hypothesis is always that they have the same ability. Our question asks, does he have a greater shooting percentage at home than on the road? So I'm going to say that Carmelo Anthony has the same ability to make a shot at home and on the road. The alternative hypothesis is the one where you say they have a greater ability, meaning that Carmelo Anthony has a greater ability to make a shot. Now, to figure out the rest of the sentence, we're going to have to use some percentages. So I'm going to take 349 and divide by the 688. I'm sorry, I just screwed that up. I went the wrong way. We're looking at home versus road. So I have to do 349 and divide by the total they shot at home. And then take the 339 and divide by the total they shot away. So 349 divided by 728 is going to be 48%. And then I'm going to do 339 divided by 774, which is 44%. So I'm going to say that Carmelo Anthony has a greater ability to make a shot at home than on the road. We just calculated some percentages, and we're going to use those for problem D. The test statistic is where you have to subtract your success percentages. So I'm going to take my home percentage and subtract my road percentage. So I'm going to do 48 minus 44, which gives me 4%. Now, this could also be given as 0.04. They mean the same thing. So that is your test statistic. Part E says to describe how to use note cards to simulate the distribution of the test statistic, assuming that he had the same ability to shoot at home and on the road. So the first thing I'm going to do is I'm going to start with 1,502 note cards that represents total number of games. Sorry, I had to change colors. That was kind of messing with my eyes. So you start with the 1,502 note cards because that's the total number of games that you have. The next thing you're going to have to do is write made on 688 and miss on 814 of the cards. So I'm going to start with the 1502. 688 I'm going to write on made on because there is a total of 688 made shots. Then I'm going to write 814 misses because there was 814 missed shots total. The next step is to shuffle. Once you shuffle, you're going to randomly place 728 cards in one stack that represents the home games, and 774 in another, which will represent the road games. Once you place them in the stack, you're going to calculate the percentage and find the difference. And that is how you simulate the distribution of the test statistic. Yes, that's a lot, but we've done this once or twice in class. So anytime it asks you to describe how to simulate, you're going to use this method. You always have to use the numbers from the problem. Okay, we're going to move on to the next page. And it's a new problem. Problem 2 says, did the 2009-2020 through the 2020 have a greater ability to win at home? And instead, that's a typo. That should be the 2010 Philadelphia Flyers. At home, they won 58.5% of their games, while on the road, they only won 41.5%. 100 trials, that's going to be important here in a minute, of the simulation were conducted, assuming that the Flyers have the same ability at home and on the road. And the simulated difference in their winning percentage from each trial was recorded on the dot plot. What information is provided from the dot plot? The dot plot shows all the possible outcomes that the Flyers could have scratch out the with. All the possible outcomes that the Flyers could have just by random chance So the dot plot shows all the possible outcomes that the Flyers could have just by random chance. In order to estimate the p-value, the first thing you have to find is the test statistic. Well, they don't give you a two-way table, but they give you the information you need in the paragraph. They say at home they won 58.5, and on the road they won 41.5. So to find the test statistic, you're going to do 58.5 minus 41.5. Well, 58.5 minus 41.5 is 17. So my test statistic is 17. I'm going to take that number and find it on my dot plot. So if that's 10, I'm going to say 17 is probably about right here. Somewhere right in that area, maybe even a little closer to those dots. So what I'm going to have to do is I'm going to have to count how many dots are from here and to the right. So if I look, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I have 11 out of 100. 11 divided by 100 is going to be 0.11. That is my p-value, and I just trashed everything. See if it'll come back. Yep. That is my p-value. So in order to find the p-value, you have to find the test statistic first, and then find the p-value using a dot plot. So after you find the test statistic, you use dot plot. Part C says to interpret that value. Well, that value basically means that there is an 11% chance that the Philadelphia Flyers and I cannot spell will have a difference in ability of 17 just by random chance. That is what the p-value means. Part D says make an appropriate conclusion. So I have to ask myself, is 0.11 big or small? Remember, anything is considered big if the p-value is bigger than or equal to 0.05. Well, in this case, our p-value is big. Therefore, I'm going to say that the Flyers have the same ability to win at home and on the road. So that is the appropriate conclusion. Problem number 3 says, do basketball players have a lower ability to make free throws when shooting granny style? Suppose that you have a basketball court and you take 30 free throws in random order. You take 15 shots granny and 15 shots traditional and record the number of shots made. What is the explanatory variable? Remember, the explanatory variable are what you're changing. Okay? So, in this experiment, you're changing the way you are shooting the ball. So, the explanatory variable is going to be shooting granny and traditional style. The response variable is what outcome are you trying to measure? In other words, are you making or missing the shot? So the response variable is making or missing the shot. Explain why it is important to randomize the order in which the shots were taken. This is really important because if you take all of the same shots in the beginning and all the other shots at the end, something could possibly happen to change the way you shoot. In other words, you might get tired after the first 15. You might get tired, or you might have gotten injured or something halfway through. So it's important to randomize the order so that the person conducting the experiment doesn't become biased. In other words, for example, the shooter could become, you can come in, tired halfway through. Some of the variables that are important to control during this experiment would be the ball, or the size of the ball. The distance you stand from the goal, or even the hand you shoot with. There are some more other important control variables that you would need to control, and you're more than welcome to list those, but those were the three that I thought of right off the top of the bat. Problem E says, in this experiment, provide convincing evidence that you have a lower ability to make a free throw when shooting granny style. Can you conclude that the shooting was the cause of the lower ability? Why or why not? So, I don't know what just happened to my screen, It's weird because I can write and then all of a sudden I move my pen down here and bring it back and then it starts doing this and I don't know why. So give me 1 second and I am going to try to fix the screen. Okay, so I got the iPad to fix. For this example, you cannot say that this experiment provides convincing evidence that you have a lower ability because it doesn't tell you what all they controlled. So the answer is going to be no because you don't know if they controlled every aspect of the experiment. Now, if they said they controlled the distance, they controlled the way they shot the ball, they controlled which kind of ball they used, then yes, you would be able to say for 100% certainty that they had a lower ability. But they do not provide you enough information to say that the ability changed. So this is your study guide. If you have any questions, please feel free to ask. Your test will be on Tuesday. Good luck.